Hi, I'm Emily from emilylearning.com, and in this video here, I'll be going through paper 3 of the A-level math paper from Cambridge International. This is for syllabus 9709. So let's take a look at the first question. The first question is a binomial expansion question. You're asked to expand this 3 plus x multiplied by 1 minus 2x to the power of half in ascending powers of x up to and including terms in x squared, simplifying the coefficients. So take note, because the power here of this binomial is half, which is not a positive integer. So therefore, when we refer to list MF19, we'll be using this formula here. Okay, remember, for this first binomial expansion formula, it only applies if n, which is your power, is a positive integer, because n is a fraction. Okay, so therefore we'll be using this. So we have 1 minus 2x to the power of half. So if you compare with this, they both start with 1, so that's great. If not, you need to change until it starts with 1. Then instead of x, you have minus 2x. Okay, and your n is half. So in other words, you replace all your n with half and your x in this formula with minus 2x. Next, you're told that you want up to terms in x squared, so therefore you expand up to x squared here. So with that, let's do the expansion. Okay, so I'll expand. I'll first copy 1. Then next is nx, so it's half times minus 2x. Then it is n minus 1 over 2 factorial times whatever you have here, minus 2x squared. I'll stop here because we only need terms up to x squared. Next, let's simplify this. So I'll have 1 half times minus 2 is minus x. Okay. Then here, I'll have half times minus half over 2 factorial, which gives me 1 over 8. This one, when expand, I get 4x squared. Okay, now that I'm done with this, let's expand. So I'll take 3 multiplied by all these terms here. Okay. So I get 3 minus 3x plus 3 over 2x squared. Next, I'll take x multiplied by 1 minus x. I'll not multiply it with half x squared. Reason is because I only need terms up to x squared. If you take x times half x squared, you get x cubed, which is not needed. So I'll just stop here. So x times 1 give me x. X times minus x give me minus x squared. Next, let's simplify. So I have 3 minus 2x oops, sorry, this one should be minus. Half times minus half times 2 factorial is minus 1/8. Okay, so I'll have 3 minus 2x minus 5 over 2x squared as my answer. Next, question 2. Solve the equation ln bracket 5 x minus 5 equals to 7 minus ln x. So because I do not have all terms with ln, so what I'll need to do is I need to bring all the terms with ln together. Okay, and we know that if I have ln a plus ln b, I'll get ln a times b, right? So that is what I'll do. I'll combine these two. So I have ln x minus 5 times x equals 7. Okay, next I want to remove the ln. So you recall that if I have ln A, B, then to remove the ln, I'll have e to the power of b equals to a, right? So that's what I'm going to do. So I know that e to the power of 7 equals to x minus 5 times x, right? Okay, so e to the power of 7 is essentially a constant. So let's simplify this. We'll have a quadratic function x squared minus 5x, then bring it over, minus e to the power of 7 equals to 0. So to find x, we will use our quadratic formula. Okay, so it is minus b plus minus square root of b squared minus 4ac over 2a. So it will be 5, because minus negative 5 is positive 5, plus minus b squared minus 4ac over 2a. Okay, so let me type it into the calculator to get the answer. So I'll get 37.709, or negative 30.709. So round off to 2 decimal place, I have 35.71 or negative 30.71. Okay, but before we do that, we need to check back, right? So what do we know? We have ln bracket x minus 5, okay, and ln x. Can we ln a negative number? No, right? So we need to reject this. So let's write it. Since we have ln x minus 5 and ln x, okay, we know that x minus 5 must be more than 0, or x must be greater than 5, and x must be greater than 0, right? If not, the ln will be undefined. So therefore, we need to reject x equals to minus 30.71. So therefore, x is equals to 35.71. All right, let's take a look at this question. Here you are given the variables x and y satisfy the equation a to the power of y equals to bx, where a and b are constants. And the graph of y against ln x is a straight line passing through these points here as shown in the diagram. We are asked to find what are the values of a and b, give each value correct to the nearest integer. So if you were to look at this graph here, it's a straight line, and the vertical axis is y, the horizontal axis is ln x. So remember, it's y equals to mx plus c, so our y is still y, but our x is ln x, so it's m ln x plus the vertical intercept, which is c. Okay, so this comes from a to the power of y equals to bx. So in order to get ln, we need to ln both sides, right? So ln both sides. So now I need to bring y down, so it's y ln a. Then this will be equals to ln b plus ln x. Now y is the subject here, so we need to make y the subject. So divide everything by ln a. Okay, so once that we have done this, okay, the next thing that we need to do is we know that this is the gradient and this is the vertical intercept. So once we are able to find this, we'll be able to find a and b respectively. So let's do it. So we'll start off by writing a to the power of y equals to bx. So I'll ln both sides. So y ln A equals to ln B plus ln X. So I have y equals to 1 over ln A ln X plus ln B over ln A. So I know that 1 over ln A is the gradient. I also know that ln B over ln A is the vertical intercept. So once that I have this, what do I do next? Well, I'll find the gradient and the vertical intercept, and from there I can find A and B. Okay, so let's do it. So I know that gradient, which is equals to 1 over ln A, is equals to, so if this is x1, this is x2, this big x1, big x2, this is, sorry, if this is x1, y1, this is x2, y2, then my gradient is equals to y2 minus y1 over x2 minus x1, right? So let's find the gradient now. So here I got 0.51334. So I know that 1 over ln A is equals to this. So ln A is equals to 1 over 0.51334, right? Which is about 1.948. So therefore A is e to the power of 1.948, which is equals to 7.0146, or 7 if you round to the nearest integer, which is what is required in this question. Now that we have found 1 over now that we have found A, we need to find out what is B, right? So let's use this formula. Okay, so sub in y and ln x. So I'll use this point. Okay, so sub in y equals to 1, x equals to, ln x equals to 0.336, and ln A equals to 1.948 into equation 1, right? So here we go, let's do it. Okay, I should also sub in this one here. Okay, so what we need to do is find what is ln B, and from there find B. So it'll be 1 minus this, okay, then the whole thing times 1.948. So ln B is equals to 1 minus this. So what is this equals to? Let me check. So it's 1. This is 1 over 1.948 times 0.336 is 0.17248. So I'll take 1 minus 0.17248, then multiply by 1.948. Okay. This will give me 1.612. Okay, and B is equals to e to the power of 1.612. Okay, which will give me around 5.01, or 5 if I round it off to nearest integer. Okay, so A is equals to 7, B is equals to 5, and rounded off to the nearest integer for this question. Now let's move on to question 4. You're given the complex number u is given by this. U equals to -1 minus I root 3. Express u in the form of this, where r is greater than 0, theta is in between -pi, and find the exact values of r and theta. Okay, so let's take a look at this. So I know that this is u, so this is the real axis, this is the imaginary axis. So if I were to plot this on the Argand diagram, the real part is negative, the imaginary part is also negative, right? So I know that the angle theta is in between, this one is 0, right? This is pi over 2. Here to here it's pi or negative pi. So this angle here is negative pi over 2. So the angle here is between negative pi over 2 and negative pi. And to find the theta here, it is basically basic acute angle. Okay, that means you ignore all the negative sign. Okay, or you can look at it as this one. Here is 1 unit. Okay, let me erase some of these numbers here. So this is our theta, right? So I want to find the angle here. So what I need to do is, this is alpha. Let's assume that this is a basic acute angle. Okay, so I will, and here is 1 unit, right? Here the height is 1 unit, and here this length here is √3. Or maybe I should draw it here. Here is -1, and here is minus √3. Sorry, here is minus √3, and here is -1, right? And this is the theta that we need to find. Okay, so here's my triangle. So if I were to look at it, it is basically negative pi, okay, plus tangent inverse √3 over 1. Right, because this is a right angle triangle. To find this angle here, ignoring the negative ones, the negative signs, it will be just tangent inverse √3, which is the height, okay, over 1. Okay, so I know we know that tangent inverse √3 is pi over 3, right? So therefore theta is negative 2 pi over 3. Okay, so in our lessons, right, we talk more in detail how to find the theta for each quadrant. So follow that rule. So if it is in this quadrant, the third quadrant, it is basically negative pi plus alpha. All right, so find what is alpha. When you're finding alpha, which is the basic acute angle, just ignore all the signs, the positive or negative sign for your real and imaginary part. Okay, next let's find r. R is essentially square root of -1 squared plus negative √3 squared, right? Which is equals to 1 plus 3, which is 4. So r is 2. Okay, so from there we know that u can be written as 2 cos negative 2 pi over 3, maybe this should be a square bracket, plus I sine negative 2 pi over 3. Okay, this is sine. Okay, next let's move on to part B. Now let's take a look at part B. So we are given the complex number v is given by this 5 cos pi over 6 plus I sine pi over 6. Express the complex number u over v in the form r e I theta, where r is greater than 0 and theta is in between minus pi and inclusive of pi. So when we are doing this, we know that we want the complex number to be in the form of r e I theta form. So I should change u as well as v to the r e I theta form. So from here, I know that r is 2, right? So for u, I can write it as 2ei, and its theta is minus 2 pi over 3. Similarly, for v, I can rewrite it. The r is 5. The theta for v is pi over 6. Okay, so with that, let's find what is u over v. U over v is 5ei pi over 6 over 2ei negative 2 pi over 3. So I can take 5 over 2, which is 5 over 2. Then simplify this portion here. It will be e to the power of I pi, so it'll be this way. Let me write it out. Okay, so when it's a division, you subtract the powers, right? Okay, so it is the same as I pi over 6 plus 2 pi over 3, which will give you 5 over 2 e to the power of 5 pi over 6. So we know that from here, the r, it's 5 over 2, and the theta is 5 pi over 6. And 5 pi over 6 lies within this range, and r is greater than 0. So we are done with part B. Alright, let's take a look at question 5. So in question 5, you are given the equation of a curve is this for x in between 0 and 2 pi, and you're asked to find dy dx and hence find the x coordinates of the stationary points of the curve. So basically, we are asked to equate dy dx equals to 0 and find what are x, because at stationary point, dy dx equals to 0. They did not ask for the nature of the stationary point, so you do not need to do your second derivative test. Okay, so let's do it. So we have y equals to e to the power of sine x over cosine square x. Okay, and whenever you see this, right, I want you to remember that we know that cosine x cannot be equals to 0. Okay, if not the denominator, because we cannot divide by 0, if not it will be undefined. If not, y will be undefined. So something to take note of here. Okay, I'll talk more about it later on. Alright, so now let's find what is dy dx. I'll use quotient rule. So to use quotient rule, I'll first copy the denominator, then differentiate the numerator, which gives me cosine x e to the power of sine x. Then next, let me differentiate the denominator to cosine x times negative sine x. So here becomes plus. Then e to the power of sine x. Then over cosine to the power of 4x. Okay, so this is what we have. Okay, so we have essentially cosine cube x e to the power of sine x, okay, plus 2 cosine x sine x e to the power of sine x over cosine to the power of 4x. Okay, so we can actually factorize it, cosine x, then we'll have, and we also can factorize e to the power of sine x, then we'll be left with cosine square x plus 2 sine x, okay, over cosine to the power of 4x. Then we can cancel away, so we are left with cosine cube x at the denominator, and in the numerator it will be e to the power of sine x cosine square x plus 2 sine x. Okay, next we want to find the stationary point, so when that occurs when dy dx is equals to 0. Okay, so do a cross multiplication, the cosine cube x is gone. Okay, so we know that cosine x will never be 0. Okay, so now I'll be left with this. So I have two factors, right? Multiplication of two factors equals to 0. That means either one of them is 0, right? So I have e to the power of sine x is equals to 0, or cos square x plus 2 sine x equals to 0. So I know that e to the power of anything will always be more than 0. So we can write, since e to the power of sine x is greater than 0 for all x being real, so therefore we will reject. Okay, no solutions for here, so we can say no solutions. Okay, no real solutions of x for this one, because e to the power of sine x will always be more than 0. It cannot be equals to 0. Now moving on this, we need to solve this trigo equation. So you have cosine square and sine. So what do we need to do? Well, we need to change the cosine square to sine square. So recall your identity, sine square x plus cosine square x is equals to 1. So therefore, I'll rewrite cosine square x as 1 minus sine square x. Okay, and then I will replace cosine square x with 1 minus sine square x. Okay, so let me write it in this form. So if you look at this, this is actually a quadratic, some sort of a quadratic equation in sine x. So you won't be able to factorize this. So let's use the formula to find what is sine x. So it'll be minus 2 plus minus 2 square minus 4 minus 1, 1 over negative 2. All right. Okay, so I'll have minus 2 plus minus square root of 8 over minus 2. So I'll have sine x equals to, let me type in minus 2 minus root 8, then the whole thing divided by negative 2. That will give me 2.4142. I will reject, since sine x will be always in between minus 1 and 1. Next, I also have sine x. So now I take the minus 2 plus root 8 one. So minus 2 plus root 8, then the whole thing divided by negative 2. I'll have negative 0.4142. Okay, let me first find basic acute angle of x. It will give, so I will ignore the negative from 0.4142. So sine inverse 0.4142. Okay, which gives me 0.4142, which gives me 0.42706. Okay, but sine is negative, so remember our quadrants. When sine is negative, we are looking at the third and the fourth quadrant. How do we find angles in the third quadrant? Well, if it's in radian mode, we will take pi plus the basic angle. And if it's in the fourth quadrant, it will be 2 pi minus this. So therefore, I have this. So I have x equals to 3.5686 or 5.856. So round off the three significant figures. So therefore, x is equals to 3.57 or 5.86 when rounded into three significant figures. All right. Okay, now let's move on to question 6. By sketching a suitable pair of graphs, show that the equation cosecant half x equals to e to the power of x minus 3 has exactly one root denoted by alpha in the interval in between 0 x between 0 x in between 0 and pi. So in other words, you need to show that there is only one intersection. Okay, so what are the two things that we will sketch? Well, we will sketch y equals to cosecant half x and y equals to e to the power of x minus 3 from 0 to pi. And we will show that within this range, there is only one point of intersection. Okay, so let's look at the graph of cosecant x first. So recall your cosecant x graph looks something like this. Okay, so we have asymptotes at the y-axis at x equals to pi and x equals to 2 pi. When if you're looking at y equals to cosecant x, right? Okay, and it looks something like this. Here is 1, and here it's pi over 2, right? Then here it's negative, the y value is -1, and here is 3 pi over 2. So this is for cosecant x. Now what happens when it is cosecant half x? Well, we are going to stretch it by 2 units, right, along the y-axis. So in other words, all these x values here will be times 2. So instead of being 4 pi, 2 pi, this asymptote will be at x equals to 4 pi. Instead of here being 3 pi over 2, x equals to 3 pi over 2 at this maximum point, now it occurs at 3 pi. Okay, here is this. Okay, and then finally we know that this minimum point occurs at x equals to pi, and this is a half x. But for this graph here, they only ask for x in between 0 to pi. So I only need to sketch from here to here, okay, from here to here for cosecant half x. Okay. Okay, so here is my pi. And then here it's 1. And because it doesn't include pi, I'll put an open circle here. Okay, to show that it is not included. Okay, let me also erase this since I do not need this. This is just for explanation. Okay, so now that I've done with this, let's take a look at y equals to e to the power of x minus 3. So we know that for y equals to e to the power of x, it looks something like this, right? Okay, and the asymptote is at the x-axis, or y equals to 0. Now, if we have e to the power of x minus 3, what happens? We are going to shift this graph, or we are going to translate this graph, okay, down by 3 units. Okay, so in other words, instead of the asymptote being at y equals to 0, it's now at y equals to minus 3. Okay, this point here, when x is 0, here is 1. So here, now it intersects the y-axis at minus 2, and this is something that you get. Okay, so let's do it. So this is how the curve will look like. So when it is pi, because we only need from 0 to pi, right? Okay, so let's find out what is the value when it is pi. So I know that this will be e to the power of pi. Okay, which is around 23 point something. Okay, so I know that I will go from minus 2, which is here, all the way to e to the power of, pi, which is way more than 1. So maybe around here. Okay, so this is how the graph looks like. I know that this point here, this is at pi comma e to the power of pi. Okay, so it's not included, so I'll put an open circle here. Okay, and why I need to know that it is greater than 1? So that I know that the graph is above this y equals to cosecant x graph, okay, at pi, so it's here. Because it could be here, right? I know it's going up. Is it here? Is it here? Is it here? So you do need to find, so you know that it's above. Okay. Okay, so now that we have sketched these two graphs, okay, let me erase this first so that it is cleaner, because this is only for explanation. Okay, now that we have drawn these two graphs, you need to say that since y equals to cosecant half x, and y equals to e to the power of x minus 3 intersect at only one point for in the interval x in between 0 and pi. Therefore, there is only, or there is, let's just follow what they say, there is exactly one root alpha in the interval from x between 0 to pi. Okay, and we know that alpha is here. This is alpha. All right. Next, you are asked to verify by calculation that alpha lies between 1 and 2. Okay, so we can let fx be equals to cosecant half x minus e to the power of x plus 3. So why? Because we want to solve this equation, right? So cosecant half x equals to e to the power of x minus 3. So cosecant half x minus e to the power of x plus 3 is equals to 0. So if I want to solve for this equals to 0, I'm finding when fx is equals to 0, right? So they asked to verify by calculation that alpha lies between 1 and 2. So I'll first let fx be equals to this. Next, I want to find what is f1 and also what is f2. Okay, so let's do it. And I know that f1 is 2.0791, which is more than 0. How about f2? I get negative 3.20066, which is less than 0. So if I know that because of this, right, if I were to draw y equals to fx, okay, here's 1, here's 2, here's x. Okay, at f1 here is positive, at f2 it is negative, right? So if I want to solve for fx equals to 0, I know that the root is in between 1 and 2. Okay, so since f1 is greater than 0 and f2 is lesser than 0, therefore we know that alpha is in between 1 and 2. Okay. Moving on to C, show that if a sequence of value in the interval between of x in between 0 and pi given by this iterative formula converges, then it converges to alpha. Okay, so we know that if it converges, we are solving for x equals to, okay, so basically it is trying to tell you, show that this is the same as this. Okay, so what I'll do is I'll start off by writing cosecant half x equals to e to the power of x minus 3, where the root is alpha for x in between 0 and pi, right? Okay, so I need to see whether I can rewrite this into this. Okay, so I have a ln here, right? So in other words, I need to put e at one side, okay, and then bring the 3 over to the other side. So bring this over. Next, to get rid of e, I will ln both sides, right? Ln e to the power of x is x. Then here will be ln cosecant half x plus 3. So now, I know that this is the same as this, right? So therefore, okay, xn plus 1 equals to ln cosecant half xn plus 3, okay? So therefore, if this converges, okay, it converges to alpha because we are solving the same equation, right? It is just written in a different form. Next, they want us to use this iterative formula with an initial value of 1.4 to determine alpha correct to 2 decimal place. Give the results of each iteration to 4 decimal place. Okay, so you need to correct to 2 decimal place, then they want each to be 4 decimal place. So we will keep doing the iteration until when we round off to 2 decimal places, okay, the value is the same. So we have x1 equals to 1.4. So x2 will be equals to ln cosecant 1.4 over 2, right, which is 0.7 plus 3. So let's type into the calculator and then correct to 4 dp. Okay, so it gives me 1.5156. Okay, then let's continue. So this one round off to 2 decimal place. Anyway, I can't do it yet. This one is 1 decimal place. I need 2 decimal place. So let's continue. Okay, so continue. So if I round this off, I get 1.49. If I round this off, I get 1.51, not similar. Okay, let's continue. So I round off to 2 decimal place. This is 1.50. This one is 1.49. So for both x4 and x5, when I round off to 2 decimal place, they give 1.50, right? So very likely, I know that alpha is equals to 1.50 when rounded off to 2 decimal place. Okay, so how do I check that alpha is the answer? So let's go back. So you can check, but you can sub in you can sub in this. You can sub in x equals to 1.495, okay, into this equation here, into fx. Then you can also sub in x equals to 1.55 into fx. Okay, so or you can just sub in any two values that is very close to this, okay, into fx here. One should be positive, one should be negative. So let me do that. So I'll sub 1.495 into this equation here. So I get f 1.495 is equals to 0.01166, which is greater than 0. So this one here must be lesser than 0. Sorry, it should be 505. Because these two are the so 1.50 is in between these two values. Okay. So I get negative 0.04102. Okay, so this is to check. So therefore we know that alpha is 1.50 when rounded off to 2 decimal places. Okay, next, so you are asked to state the minimum number of calculated iterations needed with this initial value to determine alpha corrected to 2 decimal place. So these are first iteration, second iteration, third iteration, fourth iterations. So I have 4 iterations. Okay. Let's look at this complex number question. So you're asked on a single Argand diagram, sketch the loci given by this equation and these where W and Z are complex numbers. Alright, so if you look at this format, you know that it's a circle. Okay, so let me write this out. I have this Z. I'll rewrite this as minus 3 minus 2i equals to 2. So I know that the center of the circle is 3, 2. The radius is 2 units. Okay. Next, for this one here, I know that I need to draw a perpendicular bisector. So again, I'll write it in this form. So this 3 minus 2i, and this is minus 3 plus 4i. Okay, so I need to draw a perpendicular bisector between these two. Okay, so let's first find 1 unit, 2 unit, 3 unit, 1 unit, 2 units. So this minus 2, this is 3, so this is the center of my circle. Okay, and it is 2 units, so it will touch here. Then 2 units here, 3, 4, 5 here, minus 2, minus 3, minus 4. So I know that my circle will look something like this. Pardon that I don't have a set square inside here. Okay, so this is a circle with a center 3, minus 2 and a radius of 2 units, right? So this is the locus of Z. Okay. Next, let's draw the locus of W. Is a perpendicular bisector of the line formed by these 2 points. So the one point is 3 minus 2, the other one is minus 3 minus 3 and minus 4. Okay, so if I have to look at this, if I have 3 minus 2 and minus 3 4, sorry, minus 3 4. Where's the center? Well, the center, the midpoint of this will be at 3 minus 3 over 2 minus 2 plus 4 over 2. So it is 0, 1. So this is the midpoint, right? So here, okay, so let me draw this line here. So this is the locus of W. Okay, this one is 1. Right. So next you're asked, hence find the least value of mod Z minus W for points on this loci. So how do you find the least value? So that means this is where W is likely to be at, and this is where Z is likely to be at. So they're asking you the least value. That means the shortest distance between W and Z. So the shortest distance between W and Z is basically this distance here, right? Okay, so let me mark this distance as D. Okay, so let D be the shortest, the least value of Z minus W. Okay, so how do I find distance D? Well, it is basically, I know this point here, right? This point here is 0, 1. I know this point here is 3, minus 2. And this will definitely pass through the center because this is the line. Okay, this is a straight line, right? Here is a straight line joining 3 minus 2 and minus 3, 4, right? Okay, so what I'll do is I will first find the distance between 0, 1 and 3 minus 2. Then I will minus the radius to find distance D. So D, so minimum Z minus W is essentially the distance between these 2 points. So distance between these 2 points is basically y2 minus y1 square plus x2 minus x1 square whole thing square root. Okay, then minus the radius. So when I find the distance between these 2 points, I'm finding the distance from here to here, right? But what is the minimum distance between W and Z? It is this one. This is the distance that I want. And this distance is basically the yellow line minus 2 units or minus the radius of the circle. Okay. So it's basically root 18 minus 2 units. Okay, and because they want it in exact form, okay, we do not need to type it into the calculator. Root 18 is the same as 3 root 2 minus 2 because root 18 is the same as 9 times 2. Okay, and we can square root 9, which gives 3. Okay, so root 18 is the same as 3 root 2. So the minimum value of mod Z minus W is 3 root 2 minus 2. Let's take a look at question 8. So in question 8, you're asked to use substitution u equals to 1 minus sine x to find the exact value of this. Give your answer in the form of a plus b root 2, where a and b are rational numbers to be determined. Okay, so in other words, they want exact form. So this is integration by substitution. So we need to sub all the x into u. We also need to sub the limits because this is x equals to pi, x equals to 3 pi over 2. Okay, we need to change this to be in terms of u. And finally, we also need to change dx to du. So there are 3 things to change whenever you have a definite integral and you're doing by substitution. So let's do them. So we are given u equals to 1 minus sine x. Okay, so when x is equals to pi, u will be equals to 1 minus sine pi, which is equals to 1. Just type it into the calculator. When x is equals to 3 pi over 2, u equals to 1 minus sine 3 pi over 2. Type it into your calculator, you'll get a value of 2. Okay, do this last. Okay, we know that 1 minus sine x is u. The sine 2x, probably we'll need to change it to 2 sine x cosine x. It's an identity in your formula booklet. So change this to sine 2x equals to 2 sine x cosine x. Because at the end of the day, this equation here, the substitution equation, is in terms of sine x. So it's a x, not 2x. So you need to use the double formula, angle formula, to change it to 2 sine x cosine x. Okay, but we'll do that last, okay, because sometimes we can cancel it. Okay. Okay, so I don't need to, so I know that sine x is essentially 1 minus u, right? What is cosine x? Do I want to change it now? Wait first, okay? Let's do the differentiation. We also need to change dx to du, right? So to do so, we'll differentiate. So I have this equation here. I'll find du dx, which will give me negative cosine x. Okay, then secretly somewhere, you're not supposed to write it because it's mathematically wrong. We pretend these are two terms. We make dx the subject. So you have dx equals to negative 1 over cosine x du. Okay, so dx will be replaced by this. Okay, so let's do it. So I will have 3 over 2 pi and pi sine 2x root 1 minus sine x dx. Okay, let's put these values in. So 3 over 2 pi, when x is 3 over 2 pi, u is 2. So I write 2 here. When x is pi, u is 1. Let me write 1 here. Okay. Sine 2x, let me write it as 2 sine x cosine x. 1 minus sine x is essentially u. So square root 1 minus sine x will be changed to square root u. Dx is negative 1 over cosine x du. Notice why I say don't change this first, because we can cancel off cosine x. So you don't need to go through the effort of finding what is cosine x. Okay, so that is why we are doing it this way. And from many of the A-level papers that I see, most of the time you can cancel it off. So don't be anxious. First replace your dx with du. Okay, then see what you can cancel. Then what you're left with, what that is, you cannot directly substitute away. Okay, because here you can substitute away 1 minus sine x or sine x easily, but cosine x not so easy to substitute away, right? So you see whether you can cancel from here. Okay, so yes, we can. So we do not need to do anything extra to make cosine x in terms of u. So once we have done this, we know that we can change this 2 sine x. So sine x is 1 minus u. 2 sine x is 2 minus 2u, right? So it has 2 minus 2u over root 2. Then there's a negative sign. Let's put it outside. Du. Okay, because there's a negative sign, I can also change this to 2u minus 2 over root 2, right? Over root u. But I cannot integrate with quotient rule. So what do I do? Well, I need to split it into two terms, right? I can split it into this and this. Okay? And 2u over square root u is square root u, or u to the power of half. 2 over square root u is 2, oops, let me put the 2, u to the power of negative half. So let's do the integration. So when I integrate 2u to the power of half, I get 2u to the power of 3 over 2 divided by 3 over 2. Okay, next here, integrate 2u to the power of minus half, I get 2u to the power of half over half. Then I need to sub in these values here. Okay, so now we can just type everything into the calculator. Okay, so I know this is 4 over 3u to the power of 3 over 2 minus 4u to the power of half. Okay. So I sub in 2. Okay, 1 to the power of anything is 1. Okay. So 2 to the power of 3 over 2 is the same as 2 to the power of 1 times 2 to the power of half, right? So it's 2 times square root 2. Okay, so it's 4 over 3, 2 square root 2 minus 4 square root 2 minus 4 minus 4 over 3. So this, I simplify this, minus 4 over 3 plus 4 is 2 and 2/3, or basically 8 over 3. Okay. So now, okay, the reason why I write this in terms of root 2 is because they want it in this form, a plus b root 2. So now I have 4 over 3, 2 root 2 minus 4 root 2, okay, minus 8 over 3, right? I want to simplify this. So I'll factorize out the root 2. I'll have 4 over 3 times 2 minus 4, right? Okay, so 4 over 3 times 2 minus 4 is negative 4 over 3. Sorry, this plus. Okay, minus 4/3 plus 4 is positive 8 over 3. Okay, so next I have simplified this. So 4 over 3 times 2 minus 4 is negative 4 over 3. Then there's a root 2 here. Okay, so I have negative 4 over 3 root 2 plus 8 over 3. So looking at this, I have a plus b root 2. So I should write it as a first plus b root 2. So therefore a is 8 over 3 and b is negative 4 over 3. Okay. Next, let's look at question 9. The equations of two straight lines L1 and L2 are these, where A is a constant. The lines L1 and L2 are perpendicular. Show that A is equals to 4. So it depends on you. I do not really like to write it in this manner. I prefer to rewrite this as R equals to 1 minus 2, 3 plus lambda 2 minus 1A. Okay, so I write it this way so that it's easier for me to see, because when there's a lot of KI, J's and K's, sometimes it's easier to make mistakes, so it's easier to write it this way. Okay, so since L1 is perpendicular to L2, we know that 2 minus 1A dot 3 minus 2 minus 2 equals to 0. Okay, so let's do a dot product. So 2 times 3 is 6, minus 1 times minus 2 is plus 2, minus 2A is equals to 0. So 2A is equals to 8 and A equals to 4. So we've shown that A is 4. Next, they say L1 and L2 also intersect. Find the position vector of the point of intersection. So if they intersect, that means I can equate this to this. Okay, so when L1 and L2 intersect, okay, this, okay, let me write A. A is now 4, right? So let's put in 4 is equals to minus 1 minus 1 minus 1 plus mu 3 minus 2 minus 2 for some particular values of lambda and mu. So when they intersect a particular value of lambda and mu, and that is what we need to look for. So I know that 1 plus 2 lambda equals to negative 1 plus 3 mu. Okay, or in other words, 3, maybe 2 lambda minus 3 mu equals to minus 2. Okay, So next, this line, I know for the y values, I have minus 2 minus lambda equals to minus 1 minus 2 mu. So in other words, minus 2 mu. Minus lambda plus 2 mu equals to minus 1 plus 2, which is 1. Okay, next I have 3 plus 4 lambda equals to minus 1 minus 2 mu. So 4 lambda plus 2 mu equals to minus 1 minus 3, which is minus 4. So now I have these three equations, right? Most of your calculators should be able to do the simultaneous equation to solve for lambda. Okay, so use it and solve for lambda and mu. Okay, okay, so I've solved for it. I found that lambda equals to minus 1 and mu equals to 0. Okay, if you don't want to use a calculator to solve, you can also basically just solve by simultaneous equations method. So I'll just times 2 for this. Okay, so times 2, so I'll have negative 2 lambda plus 4 mu equals to 2. Okay, then I'll take this equation 1 plus this equation 2 after I've multiplied by 2. So 2 lambda minus 2 mu equals to 0 lambda. Minus 3 mu plus 4 mu equals to mu. 2 minus 2 plus 2 is 0, so therefore mu equals to 0. So when mu equals to 0, okay, maybe I can sub it into here. When mu is 0, minus lambda equals to 1, that means lambda equals to minus 1. Okay? Okay, so I found this. Once I found this, I need to find the point of intersection, right? Okay, so position vector of point of intersection. I'll just sub in. You can either sub in lambda equals to minus 1 into this equation, or mu equals to 0 into this equation. I prefer to sub in mu equals to 0, so I know that it is basically minus I. So sub in mu equals to 0, right? So this whole thing is 0, so it's minus I minus j minus k. Minus I minus j and minus k. Okay, so that is the required position vector. Next, the point A has a position vector of minus 5i plus j minus 9k. Show that A lies on L1. So if A lies on L1, it must satisfy the equation of L1, right? Okay, so I will just put in A. So let me first copy out the equation of L1, which is L1 is R equals to 1 minus 2, 3 plus lambda 2 minus 1, 4. Yes, 4. Okay, with that, okay, OA is minus 5, 1 minus 9, right? So I'll equate minus 5, 1 minus 9 equals to 1 minus 2, 3 plus lambda 2 minus 1, 4. So if OA satisfies this equation, right, when I solve for lambda, Okay, for all three equations, they must be the same value. Equals to so here I know that 2 lambda is equals to minus 6, lambda equals to minus 3. Then from here I also know that lambda is equals to minus 3. Similarly, here minus 12 is equals to 4 lambda, so lambda equals to minus 3. So since since when lambda equals to minus 3, comma, a, so minus 5i plus j minus 9k satisfies the equation of line L1. So therefore, A lies on L1. Okay, so we have shown that. Next, the point B is the image of A after reflection in the line L2. So I know that what is A? A is minus 5, 1, minus 9. And this is L2, 2. And what is L2? Okay, L2 is R. What is this? Minus 1 minus 1 minus 1 plus mu of 3 minus 2 minus 2. 3 minus 2 minus 2. Okay, and this is A. And I know that L1 and L2 are perpendicular. And I know that the point of intersection is here. We have found in part B, minus 1, minus 1, minus 1, right? Because it's minus I, minus j, minus k is the point of intersection. So they say B is the image of A after reflection in L1. So this is B, right? So they are asking for the position vector of B. Okay, so let's first write, let B be x1, y1, z1. Okay, then I know that midpoint of AB is minus 1, minus 1, minus 1. Because if B is a reflection of A about L2, then this distance and this distance must be the same, right? So the midpoint is at here, this point of intersection. So how do I find midpoint? I know that minus 5 plus x1 over 2, okay, 1 plus y1 over 2, and minus 9 plus z1 over 2 is equals to minus 1, minus 1, and minus 1, right? So how do I find? So from here, I know that minus 5 plus x1 over 2 equals to minus 1. So x1 is equals to minus 2 plus 5, which is 3. Y plus y1 over 2 is equals to minus 1. So y1 equals to minus 3. Minus 9 plus z1 over 2 equals to minus 1. So z1 is equals to 7. So I know that position vector of B is 3i minus 3j plus 7k. Moving on to question 10. Given that 2x equals to tangent y, show that dy dx equals to 2 over 1 plus 4x squared. So I know that this one I need to do implicit differentiation. Okay. If you don't want to use implicit differentiation, you also can. Okay. In fact, I think you do not need to use implicit differentiation because there is no y here. So I'll just write tangent x tangent y equals to 2x, so y is equals to tangent inverse of 2x. So dy dx, we will just make use of the formula for tangent, right? So if you have to look for differentiating tangent, so tangent inverse x is 1 plus x squared, but if you have tangent inverse fx, then it will be equals to f prime x over 1 plus fx squared. So the modified version is not in the formula booklet, so do remember what the modified version looks like. Okay, so our fx now is 2x, right? So f prime x of 2x is 2. So when we differentiate, sorry, this is differentiate. So when we differentiate tangent inverse 2x, we will get 2 over 1 plus 4x squared. Okay. If you don't want to show, because it is 3 marks, right, this seems a bit too easy, right? So you can use implicit differentiation as well. So you have 1 over y, okay? Sorry, you have differentiate tangent y, you get secant squared y dy dx equals to 2. So secant squared y is the same as 1 plus tangent squared y. Okay, and we know that since tangent y is equals to 2x, tangent squared y is equals to 4x squared, right? So I have 1 plus 4x squared equal times dy dx is equals to 2. So dy dx is equals to 2 over 1 plus 4x squared. Okay, use this method because you need to show. Alright, let's take a look at part B. So in part B, you have asked to find the exact value of the integration of this. So one look at this, we know that it is integration by parts, because once you have tangent inverse, sine inverse, and all this, they cannot be integrated. Okay, so you need to use by parts. So the by parts formula is available in your MF 19. This formula here. So let me copy it here. So we have integration of u dv dx equals to uv minus integration of v du dx, right? So we need to let one of them be u and the other one be dv dx. The one that we can only differentiate, we'll let it be u. The one that we can integrate, we'll let it be dv dx. So we will let dv dx be equals to x. And so I'll let u be tangent inverse 2x. Okay, so differentiate u, okay, is basically what we have done in part A. That's why there's a hence. So so here we know that y is tangent inverse 2x, right? Which is what we have here, right? So we just need to differentiate it. So differentiate it, we get 2 over 1 plus 4x squared. 2 over 1 plus 4x squared. Integrate dv dx, we get v, and integrate x, we get half x squared. So now that we have done this, we can just put this into the formula. Okay, so integrate this by parts is equals to u times v, so half x squared tangent inverse 2x. Okay, and because it's definite integral, we need to put in these values later on, minus v, which is half x squared, du dx, 2 over 1 plus 4x squared. Okay, I can simplify this, so it's essentially x squared over 1 plus 4x squared. Okay, let's first finish doing this first. So I know that this is essentially half, okay, x squared. So when x is root 3 over 2, x squared is 3 over 4. Then tangent inverse root 3 then minus half times, if x is half, x squared will be 1/4, then tangent inverse 1. Okay, I'll do that later. So let's first finish this up. So I know that this tangent inverse root 3 is pi over 3, right? So I have 3 over 8 pi over 3 minus 1 over 8. Tangent inverse 1 is pi over 4. Okay, then it is basically 1 over 8 minus 1 over 32 pi, which is 3 over 32 pi. Okay. Okay, for completeness sake, I need to copy this. So now let's do this part now. So now I have here, which is an improper fraction. Okay, so what should I do? I should make it proper, right? So you can use a long division to make it proper, or you can basically just do it this way, which I'm going to show you. Okay, so I know that to make it proper, I need 4x squared. So if I have a 4x squared here, I need to times 1/4 outside. Okay. Okay, so if I were to cancel this, I'll get back x squared over 1 plus 4x squared. So this equal sign is being abide by. So, but I want to create a 4x squared plus 1 so that I can cancel away with the denominator. Okay, so to make it still equal, I'll need to minus 1 here. Okay, once I've done this, I will split this into two fractions. Okay, so this will give me 1/4 times 1 minus 1 over 1 plus 4x squared. Okay, so I am going to write this here. So it's 1/4. Then here's 1 minus 1 over 1 plus 4x squared. Then dx. Okay, so now I have negative 1/4. I need to integrate, right? So I will integrate 1, I'll get x. How about this? Well, if you were to look at the formula booklet, it looks a lot like this, right? So I'm going to copy this in. So from the formula booklet, we know that the integration of 1 over x squared plus a squared dx is equals to 1 over a tangent inverse x over a, right? So now, what do I have? I have 1 over 1 plus 4x squared, right? Here is x squared, this is 4x squared. What do I do? Well, what I can do is I can factorize out 4. Okay, then if I factorize out 4, this one will become 1/4 and here will become x squared. Right? Then I will put the 4, this is 1/4 outside, so I'm left with this. Okay, I'm going to, alright, very similar to this already, right? So let's rewrite it again. 1/4 is the same as half square, right? So if I were to integrate this, I will get my x squared is the same as x squared, but my a is half. So I have to integrate this. I will get 1 over a, or 1 over half, times tangent inverse x over a, which is half. Okay? So 1 over half is essentially 2. So this is 2x. So this integrating 1 over 1 plus 4x squared will give us half tangent inverse 2x. Okay, so integrate 1 is x. Integrate this 1 over 1 plus 4x squared is half tangent inverse 2x. Okay, and it's from half to root 3 over 2. Let's sub in the values now. So I have root 3 over 2 minus half tangent inverse root 3 minus half plus half tangent inverse 1. Okay. So let me expand everything out. Tangent inverse 3 is pi over 3. Tangent inverse 1 is pi over 4. Okay, so let's evaluate all these with pi first. So I'll take 3 over 32 pi plus 1 over 24, because 1 over 8 times pi over 3 is 1 over 24. So 1 over 24 pi minus 1 over 32 pi, because 1 over 8 times 1 over 4 is 1 over 32. There's a minus sign here. So I'll get 5 over 48 pi. Okay. Then I'll be left with minus 1 over 8 root 3, or root 3 over 8 plus 1 over 8. So this is the answer for this question here. Next, let's move on to question 11. It's a differential equation question. So in a field, there are 300 plants of a certain species, all of which can be infected by a particular disease. At time t after the first plant is infected, there are x infected plant. The rate of change of x, that means dx dt, is proportional to the product of the number of plants infected, which is x, and the number that are not infected. So if there are 300 plants, then the number that are not infected is 300 minus x, since x is the number that are infected. Okay, so since dx dt is proportional to x multiplied by 300 minus x, we know that dx dt equals to k times x times 300 minus x, where k is a constant, right? Okay, so let's write that down. Okay, the variables x and t are treated as continuous, and is given that when dx dt equals to 0.2, x equals to 1, t equals to 0. So these values here we can use to find the constants. So we know that when x is 1, dx dt is 0.2, right? So I know 0.2 equals to k times 1 times 300 minus 1. So therefore k is equals to 0.2 over 299, which is equals to 1 over 1495. Okay, so therefore I know that dx dt equals to 1 over 1495 x 300 minus x, which is the same as we write into this form, 1495 dx dt equals to x times 300 minus x. So this is shown. Okay, so next they ask us to use partial fractions, solve the differential equation, and obtain an expression for t in terms of a single logarithm involving x. Okay, so I know that I have 1495 dx dt equals to x 300 minus x. So I need to use variable separable, right? So I'll bring the t over, and I'll bring the 1 over 1495 over, and I bring this xn 300 over x over, so it becomes 1 over x times 300 minus x dx. I will need to integrate both sides, and they say I need to use partial fractions, right? So I have 1 over x 300 minus x equals to a over x plus b over 300 minus x. We can use cover-up rule, and we know that a, so when I want to find a, I'll sub x equals to 0 into here. So it's a is 1 over 300. Okay, b, I will sub in x equals to 300 into here. Okay, if you don't want to use cover-up rule, also can. You know that the numerator 1. So if I have to rewrite this, right, it will be a times 300 minus x plus b x over x 300 minus x, right? So the denominator is the same for this and this. So the numerator must be the same because of the equality sign. So 1 is equals to a 300 minus x plus bx. So when x is 0, okay, I have a 300, then b times 0 is simply 0, right? So I have a equals to 1 over 300. So when x is equals to 300, I have 1 equals to a times 300 minus 300. 300 minus 300 is 0, so it is eventually 0 times a is 0. Okay, so I'll be left with 300b. So therefore b is 1 over 300. Okay, so I know that this whole thing can be rewritten as 1 over 300x plus 1 over 300 minus x dx. Okay. Okay. So all of them have the 300, right? Let me take it out. Okay, integrate this will give me 1 over 149. Never mind, I don't want to integrate first. Okay, I'll talk about y later. Okay, I'll multiply both sides by 300. Okay, I don't want to integrate first, okay, because if not, I will have a arbitrary constant that I need to rename. Okay, or because I want to multiply the 300 over first. Okay, so now I'll start integrating. Integrating 1 over x, I get ln x. Integrate 1 over 300 minus x, I get minus ln 300 minus x. Integrate. Okay, so I'll copy this constant first, 300 over 1495. Integrate 1, you get t, then plus an arbitrary constant. Okay, you know that it is basically when you integrate 1, you get t plus c. C times 300 over 1495 is still an arbitrary constant, so I just keep it as c. Okay, so you have ln x minus ln 300 over x is essentially ln x over 300 minus x. Okay. Okay, they want to make t the subject, so we do not need to make x the subject. They want to express t in terms of a single log involving x, so later we need to make t the subject. But before that, we need to find c. All right. Then we will need to sub in when t is 0, x is 1. Okay, we don't need to sub in the x dt equals to 0.2 because this equation doesn't have the x dt. So we know that when t is 0, x is 1. Let's put it in. When t is 0, x is 1, right? So we can sub it in now. Okay, so I know that ln 1 over 299 is equals to c. Okay, so now that I found c, I can sub in c as ln 1 over 299, right? So I have ln x x over 300 minus x equals to 300 over 1495t plus ln 1 over 299. Okay, then I'm going to put all the lns together. So I have 300 over 1495t is equals to ln x over 300 minus x minus ln 1 over 299. So minus means divide, right? Okay, so if you have ln A minus ln B is equals to ln A over B, and ln A over B is essentially ln A divided by B. Okay, so it's equals to ln x over 300 minus x times 299, which is equals to ln 299x over 300 minus x. Okay, but we want to find t, right? So t is equals to 1495 over 300 ln 299x over 300 minus x. All right. Okay, so we have found the answer for that. But before that, let's type 1495 over 300 into the calculator, okay, to see whether it can be further simplified. And yes, it can be further simplified because both of them can be divided by 5. So it's 299 over 60 ln 299x over 300 minus x. Okay, so this is the answer for this question.